Welcome to the Jairus Of All live stream, where I explain all of the crazy things that I've been trying to build during the time that I've not been uploading videos, because I have bit off way more than I can chew with this project. We'll collect questions. Bryce is monitoring the laptop while I am live streaming so that he can transfer those questions to me. So if you want to ask them, go ahead and I will try to get to them. We're going to try to keep this short and sweet, but we're going to talk about what is going on with the Mantis Blades, because this part of the project has been significantly more difficult than I thought it would be, because I had an idea in my head of how all of this would go together, but nobody makes the parts that I need, so I had to build everything myself, and it was a lot of the same stuff that I did with this thing. So it's a lot of the same stuff that I've done before, so we decided not to film it because it would be redundant, and I tried to build everything as fast as I could, and obviously since it's been a while since I uploaded, it's taken a really long time, because these parts, it's extremely important that they're extremely accurate so that all of this works when I finally put it together. I don't want to do all this work and then have it not function like it's supposed to. So I drew a picture. Everything starts with this. This is the knife sword thing that'll be at the end of the movement arms, and it still works fantastic. I'm having a problem with my cords expanding when they're exposed to the lubricating oil that's inside of them, but it still retracts most of the way, even when it's old and oil saturated. So this is still great. The issue is that I finished this whole plate, and the idea was that I would bolt the carriage system to it. Now, if you're unfamiliar with the movement arms, basically what's going to happen is from the front of my arm, just like in the game, there will be movement arms attached to these small ball bearings. The sword will sit down in this trench, and then when I want it to activate, they will lift up, and this will be pushed forward. But in the game, in order for this to be entirely accurate, this moves independently from the carriage. It doesn't just move up via parallel arm movement mechanism. It is able to swing around like a sword would. It's almost like the movement arms are like an extension of your arm that allows this to move independently on the end. And that's the complicated part. I don't want to build this and have it just be kind of like the game. I've called it fully functional the whole time, and after reviewing a lot of game footage, buying the game, playing it after the update, and they took away the ability to get Mantis Blades early in the game. Waste of time. Now I've found some footage where people did high frame rate and they slowed it down, and I could actually see that the blade section does move independently from the arms, and that's the way that I got to make it. And I think it's going to look really incredible if I do it that way. So here's how I have found a way to do it. I drew a big picture. It's not terribly accurate, but it gives you an idea of how things are going to work. So this is the, I'll stand up. Can you get this in frame? Yeah? Okay. So this is the sword blade right here. The sheathy thing. And that was supposed to have these small plates that I designed welded to it that emulate what the part looks like in the game. The issue is that I wanted to bolt this to this part. And this entire time, I've been afraid that this system will be the weak point and it'll break when I get to the point where I'm actually using it. Because even though a sword goes through stuff, it still experiences a significant amount of impact, and your hand and your wrist give, and that's what allows it to slice through something. This is going to be locked to a carbon fiber frame on my arm. So if I hit something and all of that shock is directly transferred, something has to break somewhere if it isn't the gooiness of my hand or arm having this mounted to it. But this is very snug. It fits very well, so there's not a lot of give here. I don't want to break this thing. I want it to actually be usable. I want it to be resilient. So instead of bolting this on, I did all the finishing work on this, but this is going to have to get welded to it. So I'm going to spot weld it to the outer piece. That way the energy is transferred from this directly into the outer piece, into all 20 whatever of the screws that hold that piece together, into all the pieces of metal that are in it, and then into the blocks of metal that hold the titanium blade in place. That you have to look at the chain of events. Now, you might be thinking it couldn't possibly be that much force, but what we have to think about is the leverage that's going to be put into this thing. So this is about 20, I can't remember how long this is, 20 inches. With the extension arm, I'm looking at, I believe it's over 2 feet, somewhere over 2 feet of extension. So if I hit something at the end of this, even if it slices through it really easily, and it's only a couple of pounds of force out here, with the increase in force from the leverage, because it's so far away from the point that it's held, it can be a significant amount of force. I could break my servos, I could break linkage rods, I could mess up the bearings, I could bend the steel that has it connected. There are lots of failure points in this because it's an active moving system. So what I've developed at this point is that plate is welded to a bolt. I thought the bolt was going to come through the backside. It didn't. I actually welded the bolt to the face of it. I drew the picture wrong. I drew this just now. The bolt that's welded to the plate on the front is then connected to, can you see that? Mm-hmm. Okay. Is then connected to this. This is a ratchet from a ratchet wrench. So you can take them apart and get the ratchet out. And this is the pawl, P-A-W-L, that grips it. So these pieces will lock onto the bolt that is welded to this, and they will sit inside of this ring right here, which doesn't have the recess for the pawl in it yet, but this is the reinforcement ring. Interesting thing about this is, I was very concerned with making sure that this ring fit very well on the ratchet, but it doesn't. And you might think, well, you screwed up because now it's going to move around and all the force is going to transfer into whatever, you're going to rip your pawl apart. But in the ratchet itself, this ring is able to move around. Oh, there's a snap ring in the way there. Can you hear that? The tinkling of it moving around. The ratchet part, the geared part doesn't actually sit on any metal inside. It's the little tiny ring that sticks off of it that engages with the outer body, right? So that way you don't mess up your ratchet teeth. So the only support on this is a very tiny, tiny little ring that's about 1.5 millimeters wide on this side, and then a slightly larger one on this side that's about 3 millimeters. So that 3 millimeter ring is going to have support in this part, which is the outer carriage plate. Not the outermost, but the outer carriage plate. So this is the inner one. Well, I should say middle. This is the inner plate. That's the middle plate with the ratchet part held within it, which I have drawn here. It's fine, it's carbon fiber, it's strong. So those, should have got foam board. Those are the 3 pieces that get stacked up. And then I have a question mark there because it goes to a place where I didn't have enough paper to draw it. There's an outer plate that I don't have made yet that will sit on the outside of this. So this is on the knife, right? This little plate is on the, I'm going to put that back in so I don't cut myself. That plate is on the knife. These will sit across those with the bolt welded to that part and that part welded to the knife blade. And then there's a plate that goes on the outside of that. And the plate that goes on the outside, that's where the bearing is at, right? So that's where that will get its swivel from. And this plate being perfectly fit to this ratchet part in depth and everything else so that it's nice and snug. Hear that? Basically nothing. That gives extra support to this tiny little bearing so that this part can move independently from the carriage when it's on my arm. Then, after that outer plate, that holds the bearing that's welded to this plate, that will have a Delrin slider between it and the control plate, which will be indexed to the bolt that is welded to this part, that is welded to this part, that allows the whole thing to move. And that control plate will make this move around. Now, in order to get the parallel movement so that the whole thing is controllable, this part has the holes here, and that's where the movement arms will connect from the entire carriage setup to the pivot points on the hand so that this can move around. I don't have any machining equipment. I have a junk drill press from the early 90s, I think, and I have some files and a Sawzall and an angle grinder, and I don't have the stuff to make this like I would if I had a machine shop. But I'm in my friend's garage right now because he has a bench grinder, a 2x72 bench grinder that he just got, and he just got a forge and a bunch of stuff so I can use this stuff in future projects. But the bench grinder itself has made this project significantly faster. I spent many days making some of these parts, making sure they were accurate, and this is complicated for multiple reasons. To look like the game, but it also holds a servo out here at the end, a tiny little linear micro servo that will activate the blade retraction on this part. And I have that 3D part modeled. I don't have it printed yet, but I have that part modeled, and that is what is going to activate blade retraction via the microcontroller, so that everything's automated on this. But being able to do this here with better tools helped. Still don't have a mill, and I've had to make multiple parts of some of these parts because I messed them up, because the drill bit wandered a little bit, because it's a clapped out old drill press that has a lot of spindle movement in it. And when things don't get aligned, sometimes I can fix it because it matters how I set the alignment up when it gets mounted and assembled, which is what the next video is going to be about. But in some cases it was ruined and I couldn't do anything about it. And there's a reason that everything has to be so accurate. Because the parallel movement arms have to be close together to look like the part in the game, and they cover such a great distance to back here, if there's tiny variances in lengths and the way things are set up, it will translate into significant differences in the movement of the sword blade. I don't want it to come out and be aimed off to the side or twisted or whatever. Everything has to be very, very accurate, and very tiny errors can cause very big problems when I actually go to put this thing together, and I can't have that. So I've had to be very cautious and take my time and build these things as well as I possibly can with the tools that I have available to get this thing to actually work whenever it comes time to use it. There have been significant little things that have made me stop and reconsider the way that I'm going to do this. I had a picture in my head of the way that everything would go together, and if I could just get those parts, it would be so easy to just put everything together. But nobody makes any of these parts. Nobody makes the stuff that I need. Small issues like I want bolts that have a shank on them and not all thread, so that I get a really good fitment for the bearings on them. I can't find bearings that have the right distances. Now, the reason that I have the movement mechanism from this offset from the arms is because if I stack all of the stuff up that I can't make, that I had to buy, that I have to figure out how to use, it ends up sticking off of each side of this blade by, if I remember, I don't have the paper in front of me right now, but if I remember correctly, it sticks off an inch, roughly. I think it's about an inch off of each side, which makes this hugely wide and would look super stupid whenever I have it mounted on the arm, and then I have skin plates that are supposed to cover it. The forearm skin plates are gonna stick up and be super wide. It's gonna make my arm a really awkward shape, and it's gonna look ridiculous. It's kind of gonna look ridiculous anyway, but I'm trying to keep everything as accurate as I can to the game. In the game, the movement mechanism is actually just a robotic motor. It's like a many-poled, probably a reduction geared motor, maybe. that controls the movement of the blade sheath on top of the movement arms. So you have a single movement arm, and then you have synchronized motors that move the stuff, and there's a bunch of stuff that's on the game design. It's digital, it's not real life. There's a bunch of stuff that's on that design that doesn't make any sense. There's a lot of it that does make sense. I don't know how much force those things can take. It shows in the one trailer for the game that, as far as I know, is not actually in the game. The one guy holds them shut when the guy tries to open them. So they're obviously not extremely powerful, but having a motor as your damper system for whenever you're trying to cut something with it, that would give you all of your damping ability, because you just overcome the magnetic strength and then you're good. But those robotic motors like that cost like thousands of dollars, so I can't do that. And as far as I've seen, no one makes one that's about that big. Maybe they do, but even if they do, it's definitely out of my price range. And I can't build this exactly like the game, but this is also future tech that's supposed to be from 65 years, 66 years in the future. So, well, I guess they were supposed to come out in the 50s in that game, but yeah. 29 years in the future. I can't just make that stuff with the stupid tools that I have. So I'm doing the best with what I got and the money that I have available and the parts that I can get in a reasonable period of time. I guess if I had a couple of months of lead time, I could probably get one of these companies to try to custom make me a motor to my specifications, but that would cost far more than just buying a bespoke motor. So, or not a bespoke, but a off-the-shelf motor. It's been very difficult. Not only did I have to do this stuff, but I also had to figure out what materials I was going to use, what was strong enough to be able to handle the loads that I was going to apply to it, and what can I use most effectively to make this stuff as quickly as I can, but have it still be resilient enough to use. There have been a lot of decisions made in the last couple of weeks, and a lot of work being done. I've had to remake a couple of these because I've screwed them up. The alignment on these is really critical. And now I'm at the point where I'm almost ready to assemble it. So once I can put this whole thing together, then I just need to make some movement arms. And I have the Ratchet lockout system to keep this locked in place, which the reason I had to take it apart and not just use the end of the ratchet is because this is chrome vanadium steel. I got these real cheap. I couldn't find information on whether you can weld these or not, and even if I did, it would probably screw up the stuff inside. So I made my own pieces for it. Because when this experiences the impact force, and a lot of times when you do stuff with this thing in the game and the blade is out, you're actually attacking not with a slicing motion this way, but with a slicing motion with the blade forward, just like a praying mantis does. So I wanted to be able to emulate that, and that's what I'm going to be able to do with this. And this is the first protection system to keep the servo and the control rods and the movement systems from breaking. So as long as this ratchet system can hold out reasonably well to a reasonable amount of force, because it's only this far away from where the impact or the cut is at, it's going to be mounted about right here. As long as it can hold up to that, I'm okay. I test cut a water jug. I'm not going to give away how awesome it was. It was really awesome. But I don't think it's going to experience that much force, so I'm not too worried about this breaking. But then I have another 8 inches of extension and leverage going into the movement arms, so I need to build them and have something that will mitigate the force that's transferred into them when it comes back to the carbon fiber mount on the arm. I don't know how I'm going to do that yet, but once everything's together, it'll be a lot easier to figure out. That's not going to be nearly as time consuming as this. I need that ratchet system to be able to lock and unlock and transfer all of the servo movement from servo to this pivot point to this pivot point to the middle pivot point, so that it can make this thing spin. That way it doesn't move around on its own when the parallel movement mechanism is going. So that's why this part was so complicated. It's mitigating forces, but transferring everything the way I want it to be all at the same time. So to make this system work and have the retract on the pawl, these little things are mounted on springs inside of, there's sawdust in that. They're mounted on little tiny springs inside the ratchet that keeps them extended. So I'm going to have a retraction cord that goes from this to a tiny servo, so that whenever it's sitting in there, it's pushed into place so that it engages on the ratchet and it keeps it in place when I'm hitting stuff, and it can move forward and ratchet into place. That way I can swing the sword whenever I want, and when it hits something, it doesn't matter if it's reached full extension. It doesn't have a lock pin that goes in place, because then it would have to stop at that certain place before I reached what I'm trying to hit. Instead, with this system, the microcontroller can tell it swing at something when I tell it I want to swing at something. And when I swing, it'll move forward, and the whole time it'll be ratcheting into place so that when I hit something, if it is an immense amount of leverage and force that's going back into all of the rest of the system, it's locked out by that ratchet, wherever it's at. And then the servo will just stall, and I won't break anything, because all the force will get absorbed by this system, this part, this mechanism. Which is why it's so complicated. So I need to take a string and put it inside of that little tiny spring right there, epoxy it in place so that once I do swing and hit something and this is engaged, the servo can retract that back and pull it away from the ratchet. That way it can move freely again. That way I can swing, and then they still articulate, and I have these awesome Mantis Blades that work and act and function exactly like they do in the game. Real fully functional Mantis Blades that actually do the stuff that they do in the game. So, that's what's been going on. I've been sitting here for weeks working on all of this, drawing pictures and making templates, little cardboard cutouts with pins through them to figure out my movement mechanism, making sure everything's going to do exactly what I want it to do. I definitely had this plan from the beginning, but I underestimated how difficult it would be to find the parts to make all this stuff happen. I thought I'd be able to find them, and I couldn't, so now I gotta make them. That's why it's taken so long. Apologize for the lack of uploads when I promised at the beginning of the year that I would have consistent uploads. So, anyway, do we have any questions?
Yeah, we got a super chat from Joshua. He's asking, what's the first thing you will cut apart with it?
Oh, the first thing I'm going to cut apart is probably something soft so that it doesn't break right away. Water jugs, maybe fruit. I might do fruit first. There's definitely going to be gallon jugs of water. Watermelons and, you know, the typical fare. Maybe I'll play Fruit Ninja again like I did with the Buster Sword. Maybe I'll cut apart some fake enemies, attack the dummy with it. That's definitely going to happen. But I also, for you guys, I dropped some money on some Tamashigiri mats. So there's a version 2 of the giant Buster Sword coming out, and I'm going to have an actual professional swordsman here to help me test it. So I got Tamashigiri mats to test the next version of the real-life Buster Sword on, and these. And maybe we'll have a competition video to see which is better between the Mantis Blades and a Buster Sword. See which is the more effective of the two.
If something is going to break, which part of the system do you predict would go first?
All of it. All of it, all at once. Everything seems so... I've spent a lot of time on it, but everything seems like it's right on the cusp of being broken every time I use it. But after I cut that jug with this, I know that this is going to be perfectly fine. I was really concerned that this wouldn't be able to handle some of that force. Something would bend internally or go just a little bit off because it takes such tight tolerances for this pneumatic sheath to actually work and blow the blade out. I thought that would be a major issue, but after I tested it, it still works wonderfully. So that's not an issue anymore. This whole part, I'm not really sure how well this is all going to work. There's going to be a certain amount of twisting torque force that between this and the plates that it's mounted to on the sheath. And then there's the issue of these bearings. Like, what if I hit something and this bearing gets messed up? This is going to carry the majority of the load for the sword to be able to move independently. If this starts to get dented, I might lose the articulation of the blade independent of the parallel movement carriage, if that made any sense. So there's so many places where it could fail. I mean, my carbon fiber frame is outrageously strong. I would definitely be confident in standing on this. But when you're talking about this short of an area, and then the multiplication of force over the leverage from an impact, you're talking about a significant amount of energy that's being transferred into a very small area on this. Now, that's why it's important that I have some of these parts be dynamic, which is going to come into play when I do the movement arms. Is dynamicity a word? If I don't have the dynamicity in the movement arms, then I'm definitely transferring all of that energy with the leverage back into the arm, and this could shatter. When carbon fiber shatters, it's not fun, especially if it's skin tight. So yeah, there are so many failure points. It's hard for me to actually pick one that I think is actually going to be the one that's going to go. Which is why I'm trying to overbuild everything. And at least, you know, I'm like doing some math on it to see if I think that it's going to hold up. But I mean, I don't have like the specs on a lot of this stuff because either I made it or you can't get them. So I have to hope on a lot of them.
What are you going to do when the military calls and wants this tech mass produced?
I'm going to tell them good luck. No, you could definitely mass produce this. You just have to have the facility to be able to do it, the facility and the machinery to be able to do everything. So I guess I would do what everybody else does and just charge them far more than I should for it and then retire. But I would still make YouTube videos because this is what I want to do.
Is that a Yeti cup?
I don't know. It's an Ozark Trail. I think that's what that.
Walmart knockoff.
Yeah.
Oh yeah, we got Greek Gadget Guru in the chat.
How's it going, man?
You should look into Wazer. It's a desktop water jet cutter. They would probably lend you a machine for some of the more intricate pieces.
Yeah, Wazer. That would be great. They sponsored the Hacksmith, sent him a machine and a pallet full of the dust, the garnet that it uses to cut with. And James messaged them and he said, hey, you should look into sponsoring me. And they're kind of expensive machines. So they said, well, like, that's not really our thing. We're looking for, basically my channel's not big enough. But yeah, if they let people borrow them, maybe there is a chance they would send me one if I could just like borrow it for a while, just as long as they won't want me to pay shipping on it because it's not that small. But that would be great. Or if Send Cut Send wants to sponsor me, that'd be pretty cool because I could definitely utilize their service. We'll have to, maybe we'll talk to them in the near future. That way I can stop shaping stuff with files. Or, well, at least cutting stuff out takes a long time too. I might have to do some finite shaping with files on laser cut pieces, but yeah, there's alternatives out there to me using my hands to do everything. So I'll have to look into some of that stuff in the future. Any other major pertinent questions?
What's been your favorite part of the build so far?
My favorite part of the build so far is this because it looks so awesome. And it's so outrageously strong. I've made a lot of stuff out of carbon fiber now. Not necessarily on the channel, but I've played with carbon fiber enough that I'm relatively familiar with it and its strength and its properties. But every time I make something out of carbon fiber, I'm absolutely blown away at how strong the stuff actually is. It's really incredible stuff. And I overbuilt this. It's not super heavy. I mean, it's lighter than it looks like it would weigh, especially with having the steel reinforcement frame inside to tie these points into the carbon fiber really well. But man, this thing is, it's so cool looking. And I really like this part. This part's really cool too. I did a speech recently at Utah State University. They had me come out to talk to their engineering, the potential or incoming engineering students, something, it doesn't matter. I went out there to talk, and one of the main questions was, would I make an Assassin's Creed blade, which Colin Firth has made a really fantastic, amazing one. And I've always thought that there wouldn't be really any reason to do one since he made one that's so good. There's no reason to compete with that. His is fantastic. It's exactly what it is. But then recently, I was watching a friend of mine play Assassin's Creed, and in that game, I can't remember which one it was now. When you have the blade on your arm, instead of it coming out and then you using it, it actually can be extended into someone. So you can put your hand up to someone, then extend the blade, and the blade comes out with enough force that it will do the stabbing on its own. Colin Firth's blade will not do that because it relies on an old mechanism that was developed by a guy for automatic knives, where you slide the switch forward, and when you slide it forward, it loads a spring, and it releases a catch, and then the blade flies forward under momentum into the catch at the front that stops it and holds it in place. And then when you pull the switch back, it preloads a spring at the front and releases the catch, and it momentum forces the blade to the back where it's caught on the original catch that it started with. It's a really cool system, but if you tried to open that up against something, it would just go click and it would come out about that far. And then you would have to manually load it back into the catch or pull it to the front to the catch. And with this system, I could potentially make an Assassin's Creed blade that stays hidden always, because when you go to cut something, you could put your hand against it, and then it could come out, and it could cut, and it could go back in, and you wouldn't ever be able to see that anything happened. So I do want to make one now. I can't remember what the question was that started this whole time. I got way off track.
It was about your favorite part of it.
Oh, yeah.
I think you answered that.
I did.
There's a suggestion about possibly putting like leather inside the gauntlet just in case the carbon fiber cracks, that it couldn't hurt you.
Actually, that's a really good idea. The initial plan was just to put a little bit of EVA foam in here. So the idea is that, okay, so impact forces take place over really minuscule periods of time. So if you can extend that period of time, even just a little bit more minuscule period of time than what it was occurring over, you can drastically reduce the peak force that your parts are going to experience, which is what matters with this stuff. So in order to do that, more than what it would be against, like, the human body's really squishy, right? So my first mitigation of impact force is the fact that this is mounted to goo, right? But then another way to do that is to line this thing with foam. So I was going to use EVA foam. First of all, to make it super comfortable. It fits so well. But if I added foam, it would be nice and snug, and I would have a little bit more control over it, but I would also have some damping from that foam. Leather wouldn't give me the damping, but it would definitely protect my arm from carbon fiber shards were this thing to break. They would definitely stick into the leather a little bit, but it wouldn't. I don't think there would be any chance that it would penetrate through it and be able to get me. Also, well, I guess that also depends on the type of leather that I used, but that is a really good idea. That actually might be what happens if I can find some leather for cheap. Or for free. You're reading. I feel a question coming.
Greek Gadget Guru said, I didn't quite get what you're using the ratcheting mechanism for. Can you explain again?
Okay.
Maybe just like briefly.
Yeah, I'll try to briefly over. The ratcheting mechanism is actually, that's the most complicated part. So in the game, you have the parallel movement arms. I should just sum this up. That way everybody has a general idea anyway. So thanks, man. Good question. The movement system in the game is a single arm piece that connects to the rear of the blade. And then there's a motor back here that moves this around independently. I wanted to emulate that, but the only way that I can emulate that, since there isn't a motor that's the size that I need, and I can't afford one even if there is, I'm doing it a different way. So there will be a servo mounted on the arm that activates the independent movement of the blade like this, and then parallel movement arms to carry a carriage that holds the ratchet mechanism here. The reason there's a ratchet in it is because if this were just controlled by the servo, the servo and all of the control rods, cords, whatever, that connect, that go from the arm to the pivot point, up the arm, to this rotation point, they would all get potentially broken, bent, maimed when I use it because of the impact force when I hit stuff. Even though it's cutting through things, it still experiences a fair amount of force from the impact. The problem is the leverage to that point, because it's so far away, even a small amount of force becomes a lot of force. So the ratchet system is so that I can allow this pawl to engage on this ratchet and lock it into the whole frame, which is then transferred into the movement arms instead of down the control rods back into the servos and having any of those be a weak point. So the whole point of that is isolating the impact force into the stronger materials. That way I can really cut and stab stuff with this, and it's not gonna break everything back here that makes it move around. Because I want it to be able to move up and down and be able to swing like it does in the game. Yeah. Yeah, I think those, was that succinct? Does that make sense? All right.
Some guy in chat, Macero, what's your OnlyFans?
I'm not answering that. Macero. Maybe I should have one. Maybe I'd have enough money to buy the motor that goes back here if I had an OnlyFans. Probably not. That seems to be a girl's thing.
Any idea when there will be a new video? Right now.
Right now. Hopefully soon. I can't make any promises because as I go to put this together, if I screw up more parts, I don't know when it can be done. Like some of these parts take a day to make, you know. They have to be really accurate. So it's a matter of setting up a jig and making sure my drill press is actually going to drill it in the right spot, and then you know, shaping it so that I can actually index it so that I can get everything fit up because all of it's circles, it's organic shapes. Once I know that I can get this thing put together right and it's all going to work out, I'll have a lot better idea of when I can get a video out. But I think I am actually very close now. There are a lot of little things that I need to do. Like these need a hole drilled for the recess for the pawl, like back in this section. And then they need a hole drilled in from the side for the retract for the pawl. And then they need a ramp that matches up with the curvature on the front so that the force from this is applied evenly into this ring, because this ring needs to evenly apply the force into this plate, into the movement arms, and this is going to accept the other side of that also. So yeah, once I actually start assembling this, and we're filming me assembling this for the next video, if everything goes smoothly and it works, the next video should be out soon. Or maybe we'll just put a video out of me screwing everything up that I just spent a huge amount of time developing and making. So who knows? Hopefully very soon. I keep the notifications turned on because this is definitely going to be the most complex, the most awesome project that I've done to this point. I mean, unless you're like a really big fan of like Final Fantasy, so you like the Buster Sword more. I mean, this thing has so many moving parts and it's going to be so fantastic. A friend of mine from near here is going to help me program stuff. I'm not sure if he's going to be in the video or not yet. I forget to ask him, but he's going to help me program the stuff because the programming for this, with everything working in conjunction with each other so that this is very organic and I can use it very easily, is a little beyond it's way beyond my ability level currently. So pre-thank you to him for helping me get all this stuff actually functioning with microcontrollers. What we got?
How did your Nautilus rocket mass heater hold up throughout the winter?
Awesome. It works great. I have an insulated intake tube that comes through the wall with cold air now. I think I did a video on that. I did do a video on that. Yeah, that made a big difference. The only issue was that I ran out of wood. halfway through the winter. So I got a little electric heater, and I used that when I was out of wood, and then whenever I could find wood, or I found, got scrap from people cut down yard stuff, or trees got cut down, I harvested what I could and I used that stuff. But it takes a lot of time. The problem with the issue with that heater, if you're going to make one that's that size, don't. Because it takes so much time to cut up the wood into small enough pieces that it can burn efficiently in that chamber, because my feed tube is so small and the chamber's so little. It works really well. But I spend so much time cutting wood into short lengths and then splitting it into basically what amounts to kindling to keep it going, because that's how small it is, that it's not effective. I can't spend that much time cutting up wood. I need to be working on projects and, making videos. So that's the unfortunate part of it. I've thought about tearing down that section and making it far larger, but that would take a lot more work too. Time is a premium right now. So don't make it that small like I did. Screwed it up.
Screw up videos are awesome. It's nice to see you're human. When are you making the one for your left arm?
This is my left arm. I'm not going to say anything else about that.
Do you have a word of advice for aspiring creators to be more efficient?
So the name of my channel is Jairus Of All, Master of None, because I like to do everything. The thing that I didn't account for when I started this channel and I wanted to do everything was that doing everything means that it's really difficult to develop a system to become fast and efficient at doing something, because you're always doing something different. So as I learn more and more skills, I get faster at doing certain stuff, definitely. But the amount of things that I am learning to get faster at is so vast that in order to get fast at all of them, it takes significantly more time. And then there's also the issue of me forgetting techniques or things, doing certain stuff that I recall as I start to do them, that makes me faster. So advice for new makers is, if you can find something that you really enjoy doing and you don't get bored with it, which I haven't found that yet, you can get really efficient and really fast at it. You can figure out what tools you need, good tools for, and what you can spend money on. Whereas since I use such a wide variety of tools, it's hard for me to get really good tools, because I typically need tools for so many different things. That ends up being an enormous amount of money. But yeah, if you're a new maker, try a bunch of different stuff out and find something that you really like to do. And if you can find something that you think you're going to like to do for a really long time, that's going to allow you to dive much deeper into it and become really proficient at that one thing. Jairus of All, Master of None comes from Jack of all trades, Master of none, often better than a master of one. That's what I try to do. I'm not trying to be a professional at anything. I'm trying to get good, be a jack of all trades, not a master. So, but becoming a master of a trade is faster and less expensive than what I do. Find what you like to do and do that. And do it well enough that you can make enough money off of it that you can do other stuff, which is not what I'm doing. Bad business plan. Next question. And what's our time period at?
We're at 45 minutes.
All right. We're going to wrap this up real soon. So ask a question if you got it, and then we're going to get off of here.
Given unlimited time and resources, what would you say is your dream project? Besides Aquaman, of course.
Unlimited time and resources. Oh, man, there's so many options. It's going to get big. Okay, so I have projects that I want to do currently on the channel that, given relatively unlimited time and resources, I would do. I want to make my own Formula One car out of carbon fiber. I know enough about it Not that I could make the most efficient carbon fiber frame for a vehicle ever, but I could absolutely make a carbon fiber frame. It would just take time. It would be very expensive. That would be really awesome. But if it was truly unlimited, I would 100% build my own fighter jet. I mean, who would not build a fighter jet for themselves? That would, if you had the ability to do it, like, yeah, absolutely, 100%, I would build a fighter jet. Spaceship, like, why not? Unlimited. If I could live for the next couple hundred years and have all the money that I want, I would definitely build a spaceship. Rocket, like a rocket that carried me places. Submarines where I can go real deep and like check out the Mariana Trench and stuff like that. That would be cool. I mean, obviously I like the ocean, you know, Aquaman and whatnot, but yeah, if sky's the limit, then the sky's not the limit, because I would definitely make a spaceship. So that's probably the pinnacle of how insane it would get. Anything else, or should we?
Yeah, we can end it there.
Yeah?
Yep.
Thanks for watching. Hope you enjoyed. Hope this cleared up what's been going on and what's going to happen with the Mantis Blades. Thanks for watching. I'll see you very soon in a video.
Let them know we plan on doing more live streams.
Oh yeah, we are going to plan on doing more live streams, potentially in conjunction with videos, maybe offset from videos half a week, but we are going to do more. So if you have specific questions that you want to ask about projects, expect to see us more often doing this so that you can ask me directly. I like this interaction. Thanks for watching. See you in the next video.